Hi lads, so we're here looking at the question on page 8 of the Notes of Particle Physics. Okay, so the first one was looking for a label diagram of the Cockcroft and Walton setup for accelerating protons. So basically the important things that you needed here, marks were given for an anode and cathode in the tube, a lithium target and 2 helium nuclei, and for showing the high potential difference. So again, points that I would have had here, I would have shown where protons were produced in a hydrogen discharge tube and then injected into the accelerating tube, showed the high potential difference for accelerating of the protons, showed the lithium target, and then showing the alpha particles being produced. Okay, the second part of the question, it says, what is the velocity of a proton when it is accelerated from rest through potential difference of 700 kilovolts? So the big thing to remember here is your gain in potential, or your gain in kinetic energy, okay, is equal to a loss of electrical energy. So kinetic energy is equal to half mv squared, and we use the formula V equals W over Q, so W equals QV. Remember, W stands for work done. Work done is the same as energy, so we're able to equate two of these to say kinetic energy is equal to work done, or a half mv squared is equal to QV. So mass of a proton, gotten from the tables. Velocity, don't know, that's what I'm looking for. Charge, okay, so that's the charge of an electron, because the charge of the proton is the same value, just positive rather than negative, and V is 700,000 volts. So you fill in the formula, isolate down to get V by itself, and you figure out the velocity. Next part of the question says, write a nuclear equation to represent the disintegration of lithium nucleus when bombarded with a proton. Okay, so this is a formula that needs to be known. Okay, it's an important formula there, so you have that. And the last one says, calculate the energy released in this disintegration. Okay, so again, remember, your energy will be released will be basically equal to your mass difference. So you were given the value in AMU for, or you can get it from your tables, you can get hydrogen, helium, okay, and lithium, and basically there's the values. You multiply by the conversion factor, also got from the tables as we were showing in modern physics, and you get your value here in kgs for each thing. Okay, so mass of reactants minus the mass of products is equal to our loss mass, or mass difference, using E equals mc squared, the same as we were doing last week in modern physics. You can figure out the energy released in the disintegration.